And now, please welcome SanDisk Engineering Fellow Fritz Kruger.
Good afternoon, everybody. Thanks for being here. My name is Fritz Kruger. I'm a fellow with SanDisk Corporation, and I'd like to talk to you a little bit about the fact that silicon does not spin, blah, blah, blah. And in the beginning, so 1956, IBM creates the first hard drive, the 350 disk drive, 5 megabytes of data, 600 milliseconds speak time, and it spawns a revolution. So much better than tape at the time, so much better than a bucket of paper. And very quickly things got denser, faster, smaller. And so, in fact, areal density of hard drives beat Moore's law, and in fact started well before the integrated circuit. So it's really been going for quite some time. But an interesting kind of chocolate in your peanut butter moment happened in the mid-90s, and that's when the SSD came about. And the DNA of the hard drive and the DNA of the emerging flash memory technology began to mix. And we had this almost Cambrian explosion of devices that have come out of this. Yet I would argue that at this point, we are in a strange little ecological niche, even with all this diversity and all this current growth. And that's because you still have flash stuck inside of an HDD shell in so many ways. So I'd really like to take a moment and think about what happens when you try and look at the flash DNA all by itself, away from the DNA of the 40 years of legacy of the computing infrastructure of hard drives. So one thing here is form factor. So pure volumetric. You get a beautiful 170 gigabytes per cubic inch in a hard drive. These are last year's numbers. 70 gigabytes per cubic inch in SSDs. Those have come up quite a bit in the last year. But if you just look at one of these little sticks that we saw are booting the Facebook servers, or the new ones, it's 100 or 10x easily, right? So, if we redo the form factor, take away the hard drive legacy, what value can we get from that? Power. There's a lot of discussion about that. One of the points that I'd like to ask you to do is start thinking about joules per bit, or joules per bit per second. Those are important metrics, and we tend to think of watts per slot. That may not be the best thing to think about. Performance. This is the one we're all familiar with SSDs. There's clear value proposition there. The latency and bandwidth we're getting from SSDs are fantastic. But silicon itself, we can make as parallel as we want. We can just keep plopping down chips in parallel. And if we continue to constrain ourselves behind legacy interfaces and the like, we'll never see that benefit. So where is it we're going to go to see not only the physical infrastructure change to get that benefit of parallelism, but the software and API infrastructure so that we can recognize that bandwidth. Resiliency. Hard drives have a set of particular failure mechanisms, head crash being the really killer one. And silicon does too, but silicon has a totally different set. Silicon doesn't have head crashes. Silicon doesn't spin. So in general, what happens in silicon, a die goes up in smoke. But in a storage system, you have hundreds of die behind a controller, let's say. So 99% of your system is still good, yet in many resiliency systems, we treat it like a hard drive, and we go rebuild everything. Well, it's kind of silly. Cost, obviously, this is the critical thing. So hard drives are still fantastic. They're not going anywhere. They're, the cost per bit and the availability, the number of bits produced each year, make them very valuable. But fundamentally, we have to go look at the entire solution. And this is where SSDs have proven that there's value in solutions as they exist today. So my call and challenge to you all is to go find ways to go talk about these these flash technologies, and for that matter, any non-volatile memory technologies. Don't just pigeonhole it into a fast HDD paradigm. As Matt Cordry said earlier today, talking about servers, don't just reimagine ways to put things in the tin box. So why here? Now, lots of companies outside are actually doing this in really interesting ways and building appliances in reimagining how flash should be addressed and how it should be used. And they're doing really fantastic jobs and really interesting things. But what they're also still stuck a little bit into a box because they're having to fit into a legacy data center infrastructure. And so here, the reason that I want to work in the Open Compute group is because we get to re-envision the entire data center, the entire rack, the entire software infrastructure. And that's where I think the true value can come. So the graphics here are a little funny. But anyway, so my name is fritz.kruger@sandisk.com. No, that's not my name. That's my email address. We just want to close with a quick quote from Carver Mead, the great Carver Mead, who said, "You've got to listen to the silicon. It's always trying to tell you what it wants to do. Don't put it in a box." Thank you very much.